All right. Sorry I had to jump into the middle of this build here. I've been working on this build, this battery pack build for a couple nights now, and I guess I just wanted to show you guys. I apologize for not being able to start from the very beginning, but anyway, well, we're here now. So this battery pack is spec'd at 72 volts, 42 amp hour, and 400 to 450 amps of discharge. These are moly cell P42A cells, and the configuration is 20S 10P. So there's two tiers, as you can see, one, two, and there's 10 rows and there's 10 columns. And since there's two tiers, that's equivalent to 200 cells, which is 20S, 20 in series, and 10 in parallel. So 20 times 10 equals 200 cells. This particular pack fits directly into the Razor SX500 frame. You would have to flatten out, I believe, the rear portion of the frame at the battery tray, but the sides remain the same. So this fits on into the SX500 with the battery cover still intact. So you don't have to go without it. I'm building this for a friend. He's going to be running a QS 165 version 2 motor with one of those Midwest mini mods swing arms. So he wanted me to make him a battery pack for it. Currently, he's on 72 volts. 70. He's on 72 volts, 40 amp hour, I believe. Yeah, 72 volts, 40 amp hour, and like 120 amp discharge on a QS 165. So, needless to say, he felt like it wasn't enough power. He wants to be able to push more into it, and this is going to do it. This is probably going to be the biggest battery pack I've built for the SX or any Razor frame. The trays are custom 3D printed. I sized them accordingly, and so what I did here was these strips running across here. These are for the balancing. So these are fairly thin. These are 0.1 millimeters thin, and I think 0.7 in thickness. These don't need to be thick at all. This is primarily just for balancing. So there's not a lot of current that goes through here. There's very little current, as a matter of fact. You can put a very thin strip. But these connections here, these are the series connections, and these things need to be able to support all the current that one cell can put out. So these cells are the P42A. They can put out, at least on paper, for 45 amp continuous. These are spec'd for over 60 amps. These are, you can see that these are not the same size because I had to cut these out of nickel plated copper. They're 0.3 millimeters in thickness, and in width you can see that they kind of vary, but the smallest width is at least 10 millimeters. So this little series connections here, these series connections here, they all support over 65 amps, 60 to 65 amps. Yeah, so nickel plated copper. I use that for high drain batteries. Otherwise, I normally just use nickel strips, but since this is a high drain application, I wanted to make sure that I had enough headroom. So these are the series connections, these little tiny strips here that I cut out. These are for the balancing, and yeah, and this is the negative terminal bar. So you can see what I did here. Um, right here, I have it spot welded from let's see, this would be negative. Um, no, whatever this is, I have it spot welded from going from here to the other end of it, and the reason why I have it wrapping around this way is because it keeps the bus bar on the outside. If I were to have, for example, if I were to have spot welded this to the second tier, if I had both tiers just spot welded just like this and folded it over, you can see the obvious problem. The problem would be that the terminal bus bars are essentially right up against each other. And needless to say, a hazard waiting to happen. So what I do is I wrap it around. These connections, there's copper underneath. There's how much copper is underneath here? I think there's 0.2 millimeters by 10 millimeters thick copper strip underneath, and then on top of it, it's 0.15 or zero point 0.2, maybe zero point 0.2 nickel. It's essentially a nickel copper sandwich, and each one of these connections here are the series connections, and these also support over almost 60 amps, I think, something like that. Anyway, so let me show you the other side of it as well too. You can see it's very similar. Here's the positive bus bar that I'm going to put on, and is there anything else I want to cover here? No, I think that's it. I don't think there's anything else I want to cover. Um, so you guys get to watch me spot weld, the bus bar on, and the way I'm going to do that is I'm going to use some of this grid here. I'm going to use some of this nickel grid and sandwich it with copper. So instead of having it running down this way vertically, I'll have it running horizontally this way. And I think I'm going to have, um, I think I'll have a copper grid going across this way, and then I'll have maybe two nickel grids on top. So it'll be a 3-layer. It'll be copper, nickel, nickel. And that should be able to, and I'll check my chart again. That should be able to support the current of 45 amps. And then after I have the bus bar on, what I'll do is I'll run um, I'll run the negative connection. I'll separate the negative connections into increments. So instead of one thick like 0 gauge wire, I'd have maybe 5 thinner ones. And I think I calculated out to where I can have 5 10 gauge ones. So if that's the case, if I have 5 10 gauge ones, then I'll need to reinforce the bus bar to be able to support more current. Essentially, what I need to have, or what I want to have, is if I separate it with by 5 different increments, this bus bar needs to be able to support 400 amps divided by 5. What's that? That's 80 amps. So each section of the bus bar on top here going across this way will I'm going to make it so that it can support at least 80 amps. Probably have it support around under 100 amps or so. And the reason why I do that is if I have, for example, if I have um, a connector, or if I have these branch strands connecting at let's say this point, this point, this point, this point, this point, and so on. The current flowing through that section above the bus bar needs to be able to support current enough of the current for 2 of these cells. Yeah, so I'll return to the video when I have the bus bar on, and I can show you in more detail about what it is I'm describing.